You just submitted your chapter 3 and your supervisor asked, where is your Cronbach's alpha and what does it tell us about your study? Now, most students freeze at that question, not because they are not smart, but because no one has ever explained what that number means or how to get it. So by the end of this video, you'll be able to know what a reliability is, what a validity is, what a Cronbach's alpha is, and how to get your Cronbach's alpha. Also, in addition, how to report it exactly in your chapter 3. Now, let me start with something that you already understand before introducing any research terminology. Now, let's, for example, you want to know what the time is. So you pick up a clock, it has a battery, it is running, you check it against your wristwatch, against your smartphone, against your colleague's watch, and every time it matches. Now, that clock is valid and reliable. Now, it is valid because a clock is the instrument that we use for measuring time, for checking time, and it is reliable because every time you use it, it gives you a consistent result. Now, same situation. Let's say you want to know what the time is again. Then you pick up a weighing scale. A weighing scale is an instrument that we use for checking our weight. We don't check time using a weighing scale. So no matter how good that weighing scale is, no matter how expensive or how beautiful it is, you can never check time using it. So it is not valid. It is not the right instrument for answering that question. Now, validity in research asks exactly one question. Does the instrument measures what it claims to measure? Now, this is where most students get it wrong. You set out to measure the knowledge of nurses about clinical nursing research, and then you design your questionnaire carefully. But when someone goes through those questions, they realize that those questions are actually measuring attitude, not knowledge. So no matter how good that questionnaire is, whether nurses agree or disagree, whether they feel comfortable or uncomfortable, and even if your supervisor approves those questions, they are not valid because those questions are for attitude while you are measuring knowledge. So how do you establish this validity? Now, this is where content validity comes in. Now, what I mean by content validity is simply when you are done with your questionnaire, you submit it to your supervisor, and then maybe they are going to have a panel, your supervisor and their colleagues, to look at those questions and see whether these questions are actually measuring what you intend to measure. So if there's any correction, they are going to point out those corrections and you are going to make them. So once you've confirmed your validity, you know that that instrument is measuring what you intend to measure. The next question is, does it do that consistently? That is what we call reliability. Now, back to the clock analogy. Let's say you want to know what the time is. So you pick up a clock, you check the time, and it is 10 a.m. So you went where you want to go, you came back an hour later and still checked. The clock is stuck at 10 a.m. You check it against other clocks. You're seeing that, okay, other clocks are saying it's 11 a.m. already, but that particular clock is telling you that it's 10 a.m. You check it again and again and again. Now, the reason is because the battery is dying or something is stuck. So that clock is not reliable because it's not giving you a consistent result. You can't rely on it to give you the accurate time, even though the clock is valid because it is the right instrument for checking time, but you cannot rely on it. Now, in research, reliability asks one question. If I give this questionnaire to similar people in similar condition, will I get similar results? If the answer is yes, then your instrument is reliable. But if it is no, then something is wrong. So here is an example. You designed a questionnaire to measure the knowledge of nurses about clinical nursing research. So you gave it to nurses in ABU teaching hospital, nurses in Aminu Kano teaching hospitals, and then you gave it to nurses in OAU teaching hospitals. Now, 3 tertiary institutions, similar clinical environments, similar clinical training, and similar population. Now, if those questionnaire produces completely different data across all 3 groups, then something is wrong. Is that a problem with the nurses? Not necessarily, but it is also a signal for you to look at your questionnaire to see if there's anything that you can correct for it to produce a consistent and trustworthy data, because a reliable instrument should produce a similar result when administered to similar people in a similar condition, and that similarity of results is what we call internal consistency. The most common way to measure this internal consistency is using Cronbach's alpha. Now, a Cronbach alpha is a statistical measure of internal consistency. It tells you whether the items within a section are measuring the same construct. Now, if you have 7 knowledge questions in your questionnaire, the Cronbach alpha tells you whether all of the 7 questions are measuring knowledge, whether all of them are pulling in the same direction, or there are some measuring something else that are going to dilute your knowledge results. Now, the Cronbach alpha has a value that ranges from 0 to 1. So the closer your value is to 1, the higher your internal consistency, the stronger it is. But when you are moving towards 0, when your value is moving towards 0, your internal consistency becomes weak, and that will make your result not to be reliable. So on your screen is how to read that number. So if you have 0.9 and above, you have excellent instrument. But then if you have anything below 0.6, then your instrument is poor. Now, in most research, or let me say in nursing research, the acceptable number is from 0.7 and above. Now, since you cannot give your respondents your questionnaire to answer until you've checked the validity and the reliability of your questionnaire, let's talk about how you can get data to use in your SPSS to know whether your instrument is internally consistent, is reliable or not. Now, the cleanest way to do this is by using your pilot data. In case you don't know what a pilot data means, you get a pilot data when you conduct a pilot study. Now, a pilot study is when you administer your questionnaire to people who are similar to the population that you are trying to study. So those people are going to answer your questionnaire, and then you can get data to analyze in SPSS before giving it to your final sample sites. So for example, if I'm conducting a study among nurses in ABU teaching hospital, I will carry my questionnaire to maybe Aminu Kano teaching hospital, administer it to nurses in AKTH. Those nurses are going to answer my questionnaire, and that will give me a pilot data that I'm going to use to check my reliability before giving it to nurses in ABU teaching hospital. Now, typically, you want to give your questionnaire to maybe 10 to 30 people should do for your pilot study. You don't have to study everyone. You don't have to sample everyone. It's just a pilot study. Now, your pilot study does 3 things for you. The first one, like I said, is you can use the data to check your reliability. The second one is it tells you how long it takes for people to answer your questionnaire in terms of the timing. And also, it tells you whether those questionnaires are clear and understandable. You can ask the participants. Now, if you did not conduct a pilot study and went straight into your data collection with your actual study population, you can still conduct your reliability test. You can still run the Cronbach alpha with your actual data and report it like that. It is not ideal, but it is acceptable and widely done. Now, allow me to walk you through the SPSS steps in getting your Cronbach alpha. And for this, I'm going to use an actual example. So I studied nurses' knowledge and attitude towards clinical nursing research. So I'm going to use the data that I collected for this study to show you how to run it. Now, on your screen is my fresh Excel data, downloaded straight from my Google form. Now, after you download your data, all you have to do is to open your SPSS. Once it opens, you're going to see a tab like this. Just close it. You will see an interface like this. Now, once you are done, all you have to do is go to File and then go to Import Data. Then scroll to Excel. You are going to double tap on that Excel, and then it's going to show you a dialog box like this. I'm just going to move up here and search for my file. It should be my download because I downloaded it. So now all I'm going to do is to highlight it, and then the file name will appear here. And then I'm going to click on open. Now this is a preview of how the data is going to look inside your SPSS. Just click on OK. So in case you're using SPSS that is not responding, so instead of clicking on OK or open, you can just clicking on paste. Now this is my clean data in SPSS, and in this SPSS I have both knowledge and attitude data and even barrier data. So what I'm going to do is I'm going to locate my knowledge questions. Actually, it's 7. So I'm going to look at it and know the variable because I'm going to need it. Questions are from V9 to V15. So what I'm going to do now is I'm going to record the variable because the way the data is, you cannot actually run a reliability test on it. To record this data, what I'm going to do is I'm going to go to transform. So when I click on transform, I'm going to go to record into different variables. When I double click and open it, it's going to open this dialog box. So this dialog box, you can see on the left is our variable, all our questions that we have in this SPSS. I'm going to select my knowledge question because I'm running reliability test for knowledge questions. So I'm going to select those 7 knowledge questions and hit on this arrow, and then you can see the variables have moved into this dialog box. Now what I'm going to do is I'm going to start the recoding process. So on this output variable box, I'm going to rename this variable because I want to be able to differentiate them, the coded one from the ones that are not coded. So since they are knowledge items and knowledge starts with K, I'm going to use K. I'm going to use K1 to K7. So you can choose any name that you want. What I'm going to do is I'm going to highlight on the variable 9 and I'm going to name it K1, and then the level 2 I'm going to leave it as K1, but if you wish you can have a different name and a different label. So when I'm done, I'm going to hit change, and then I'm going to go to this variable number 10. I'll do the same thing, go to the 11th, the 12th, the 13th, the 14th, and the 15th variable. Each time you click on change, instead of the question mark it's showing, it's going to be showing the new name and the new label that you used. So you can see here, instead of the question marks it showed before, I'm having K1, K2, K3, K4, K5, K6, and K7. And once you are done, you come down here and click on old and new values. On your left you can see old value, and then on your right you can see new value. Now what this old value means is what your variables, what the responses are currently known as. Remember, this is a knowledge question, so my respondent either answered yes or no. So the yes or no that they answered is the old value, is what I'm going to be putting here. So in case you are checking reliability for a Likert scale item or for attitude item, you know that their responses are going to be either agreed, disagreed, or strongly disagreed, something like that. So those will be your old value. I'm going to put yes here, and the new value is your coding value. Remember, your questionnaires are usually in string format, so you want to change them to numeric format, to be numbers, to be able to do some kind of analysis. So in order to code it, I'm just going to say that 1 is going to represent the people that answered yes. So if you answered yes to my questionnaire, automatically it's going to change to 1, and then if you answer no, it's going to change to 0. Once you are done, you just click on add, and I'm going to impute for no. You can see it is here. Now another thing you have to note is you don't have to contradict what is already in the SPSS, because if everything here is small letter and then you are writing big letters in this place, it's not going to correlate, it's not going to recognize the old value. So the way it is in your SPSS, that's how you are going to type it here. If not, it's not going to recognize it at all. So when you are done, you click on continue and then click OK. This interface is going to appear. All you have to do is to go and minimize it. You want to scroll back to the end of the data, and then you can see the variables that you coded. Now you can see we have from K1 to K7. So your data is coded and is ready for you to run your reliability test. To run this reliability test, all you have to do is go to analyze and scroll down and look for scale. You look for reliability analysis and click on it to open it. Then you are going to see this dialog box again on the left with all our SPSS variables. And all you have to do is to scroll down to find your coded data. So you can see it is here, K1 to K7. So you highlight them and click on this arrow to move the items to the items box. You come down here where it says the model and make sure that it is in alpha. And once you're done, you just click on OK, and then this is going to appear. Now you want to scroll a bit and look for where it says reliability statistics. This is the only box that we are concerned with. Look here, you see Cronbach's alpha. Now the Cronbach's alpha here is 0.419. 0.419. This is your Cronbach's alpha for your knowledge items. This is what you would report. Now you can see that this alpha is 0.4, which means the questionnaire is poor, the instrument is poor. All I need to do is to go back to my questionnaire and see if there are questions that I need to revise, or if there are questions that I need to remove in order to make my Cronbach alpha to go up to an acceptable level. Now, if your questionnaire has 3 objectives, you probably would be running this Cronbach alpha, this test, for all the 3 sections. If it has knowledge, attitude, and practice, you might want to check the Cronbach alpha for all of this and report them in your chapter 3. Now let's talk about how to report your reliability section in your chapter 3. Now on your screen is a sample of how you can report this in your chapter 3. All you have to do is to input the places, the numbers, and the people. And if there's anything that you don't understand, you can simply drop your question in the comments. And if you want to report for the rest of your objective, you don't have to write it in a different paragraph. The moment you finish writing, the Cronbach alpha for knowledge was maybe, let's say, 0.8, indicating good internal consistency. You now put for attitude it was 0.9, for practice it was 0.7. You just report them all together. Now, if you want to report your validity, you are reporting the expert review process, how the supervisors reacted to the questionnaire, what corrections were made. If there's anything here that you didn't do, you can actually remove it. And if you've done more than this, you can actually include it. If you have not yet designed your questionnaire, you can check on that video. I'll put the link in my description, because you need a well-constructed questionnaire before validity and reliability will mean anything. And next week, I'll be covering data analysis, what to run, how to run it, and how to present your findings. And when that video is ready, I'm going to link it right here. If this video helped you or solved your problem, please subscribe to this channel. That is all I am asking. And I'll see you in my next video. Bye.